ओके आ गया, चल बस बस समझ गया मैं। ओके
कॉल कट करो।
नहीं 1 मिनट का अभी चल रहा है, वॉइस कैसा आ रहा है मालूम कैसे पड़ेगा। हाँ लाइव आ गया, चल मैं। हाँ तू देख। हाँ कॉल कट करो।
गो लाइव कर।
हाँ गो लाइव कर रहे हैं ना, 1 मिनट लाइव ही है, डोंट वरी।
नहीं लाइव नहीं, एक सेकंड मेरे को अभी तक फिर ये क्यों नहीं आया, नोटिफिकेशन क्यों नहीं आया मेरे को? तो लाइव नहीं गया है बॉस।
कैसा करो गो लाइव फिर? लाइव इधर लाइव 2 पॉइंट
राइट हैंड साइड कॉर्नर में गो लाइव है।
हाँ
ऊपर ऊपर
हाँ
स्क्रीन की तरफ कैमरा कर।
1 मिनट। हाँ ये देख स्क्रीन की तरफ। See, it is showing live.
It is showing live. Why am I not getting notification then? Let me see. I'm able to see. Now speak.
Can you hear me? Can you hear me? Can you hear me? हाँ ये लाइव है बराबर, एंड नेवर आगे अपने इधर जाने YouTube किधर था? YouTube नहीं, WhatsApp। I'll tell you what has happened. कौशिक 1 मिनट रुक, क्या हो गया है? व्हाट्सएप से मेरे को आने का 1 मिनट रुक, मैं 1 मिनट मत रुक। ओके अरे व्हाट्सएप वीडियो कॉल बंद कर रहा है मैं। You know what has happened? They are not able to access now because हाँ अभी बराबर है। अभी I have to go via this so that she will be able to। वो लोग देख पाएगा। They are not come। इसको बंद आ गया प्रिया। Priya, can you hear me? Priya, can you hear me? हाँ ये हो गया ना, गड़बड़ हो गया था किधर। दिस इज टू गो देयर फिर। Priya, can you hear me now? Okay, अरे reply यार, I'm waiting because what happens when you don't reply? Okay, don't worry, no problem. We'll start today. Huh? No, I thought it's a lag. Na, you didn't understand. I think putting on this light has made a bigger difference on the quality of. इसको पकड़ ले। हाँ बस बस बस, it'll be easy for me. बस बस बस. That's it. That's it. Let the others come. By the time I'll check up with. होगा. He'll call ना streaming. Okay, we are live basically. That's a problem. Let's start. I'm not going to wait. Tavishi has come. Tavishi, can you hear me?
Yeah.
Okay, let's start. So today we are starting with the next topic. Last time we completed group 15. Today we are starting with group 16. Group 16. This is the first lecture of group 16. We need about 3 to 4 lectures for group 16. Then 17 will be 3 lectures, 1 lecture will be 18. This is the target. So which are the elements belonging to group 16? The elements belonging to group 16 are oxygen, sulfur, selenium, tellurium, and we have polonium. Now the first point is this group of elements are called as chalcogens. They are called as chalcogens. What does the Greek word chalcogen mean? The word chalcogen means that it is ore forming. It is ore forming. You can see most of the ores that are present are either ores of what are ores basically? Ores are minerals from which we can extract the element economically. It should be economically viable. So all ores are minerals, but all minerals are not ores. So ores are those minerals from which that element can be extracted. So most of the ores that we find generally, okay, they are either oxides or sulfides. What is the difference? So that's why it is called as chalcogen, because it is ore forming. So oxide ore and sulfide ore. So what can be the difference? Why should there be a separate sulfide ore and a hard elements? Like for example, Fe2O3. Okay, their ores are oxide. Whereas you take soft elements, zinc sulfide, galena. So elements which are hard by nature, they generally form the oxide ore, and elements which are soft generally form the sulfide ore. So this is mercuric sulfide, cadmium sulfide. These are sulfide ores because these elements are soft metals. You have titanium oxide. That will be, but titanium is a hard metal. Zirconium oxide, so that will be an oxide ore. So hard. So generally there is a thumb rule that hard elements will have oxide ore, and this will be okay. So that is chalcogen. Now what is very important is, okay, the second question, that before we go into the electronic configuration, the second point is, now you see there is always two type of question. Which is the most abundant element in atmosphere? Which is the most abundant element in Earth's crust? So whenever they ask this question, read the question carefully. So when it comes to oxygen, it is the most abundant of all element in Earth. That means we are including Earth's crust and atmosphere and everything. Earth's crust will be different. Fe will be the most abundant element in Earth's crust and in Earth. So there's a very subtle difference that you have to understand. So it's the most abundant of all elements. Most abundant of all elements in Earth. I am being very clear, it is not Earth crust. It is Earth. It is clear. Then it is, they also have given a figure. This figure is very important. This value is very important for factual work. It is 46.6% by mass of Earth's crust. So if you talk about Earth's crust, it is 46.6% of Earth's crust. Mainly it is present in the combined form
So this is earth and this is earth crust. Top layer of the earth is earth crust. So that's one more thing which can be asked as what do you call as a factual question. Is this clear? Then what happens is, what are the ores? We come to occurrence. Okay. When we come to occurrence, oxygen is, that is there. Sulfur occurs as what? We don't have to talk about oxygen because I've already told you. It's in the atmosphere as oxygen. About 20% of your air is uh, what do you call? Oxygen. It is clear by volume. Then when you come to sulfur, okay, what happens? Sulfur exists in the combined state. Sulfur exists in the combined state. Sulfur exists in the combined state as what? It is gypsum. Gypsum, if you remember, is calcium sulfate 2H2O. Okay. Then you had Epsom salt. Epsom is a place in Epsom salt. Okay. What is it? It is magnesium sulfate 7H2O. Now you see, this Epsom salt has a very interesting what do you call has a very interesting history. There is a place in England called Epsom. Now what happens to this? What happened there was they realized that they drink the river water. They were having purgative feeling. They were getting purged. Purged means they were going for toilet many a times. It is clear. So then they were thinking, what is causing this? So they took the river water, distilled it, and what they found was magnesium sulfate. So magnesium sulfate, one of the medical uses is it is used as a purgative. But a very strong purgative means you can get dehydrated. So in those days, this was used. But Epsom salt is still available, you know. But another use of Epsom salt, this magnesium, it's a mordant. So when you have suppose some dress which what do you call bleeds, the color bleeds, you know, you can do is buy from the medical shop Epsom salt, 2 big packets, and put in hot water and soak this. So it is a mordant. The next time your dress may not bleed, you know. So that's one use. But Epsom salt is used as a purgative. So remember that. Especially those who are NEET students, they may expect you to know, you know, because we have some small topic called as chemistry in everyday life. Okay. But of course, purgative is not there in that. Then what happens? You have barite. Barite is barium sulfate. Barite is barium sulfate, and then you have H2S. Now you may wonder why H2S. See, I'll tell you, this has got a very interesting application in our day-to-day life. You must have seen that those who are working in oil rigs and certain places in a petroleum company, especially those working in this Gulf countries, some people are very strange, what do you call, and oil rigs mainly. They have very strange working pattern. They work 1 month, 16 hours in a day, and they are given 1 month paid leave. They come back home, they enjoy life. They say, what a great, you know, I'm working for 6 months but getting 12-month pay. The reason is when you drill for oil and gas, one of the component which comes along with the oil and gas is H2S. And H2S is a neural toxin. Continuous exposure to H2S will cause what we call as paralysis of the nerves. So that is why they are given 1 month work and 1 month what do you call leave, so that they can detoxify. That is an International Labour Organization specification. So you should know that. So if somebody says, I am working 1 month and I'm getting 1 month leave, don't be happy. He's, God knows when he's old, now he'll have all kinds of paralytic problem and all that. It is exposure to H2S. Is this clear? So there are some tidbits, if I tell, it will be always useful. So that contains, then what happens is, then we have selenium and tellurium. Selenium and tellurium They occur as selenides and tellurides. They occur as sulfides, okay? Occur as sulfides, okay? Then what happens is polonium. Polonium occurs in nature in uranium mines. One very important point as far as polonium is concerned is, you know, Marie Curie was a fun. See, what Marie Curie did was she took one uh, 1 ton, that means 1000 kg of uranium ore. Is this clear? And from that she got only 0.1 milligram of polonium. Now she got a Nobel Prize for that. Now, why she got the Nobel Prize was not the discovery of polonium, not the isolation, not discovered. Polonium exists was known, isolation. The chemical engineering technique that she established to isolate radioactive element is a standard which is even followed today from ore. So that was the skill of Marie Curie. Is it clear? Marie Curie and her husband Pierre Curie. Marie Curie got she was from Poland, so that's why it became polonium. The second most important question from the entrance exam point of view is polonium is the most radioactive. It is the most radioactive element. Now that we are in the era of what you call the Russia-Ukraine war, yeah, the very interesting thing about polonium, there was a dissident, dissident means fellow who was always talking against Vladimir Putin and living in England. I forgot that fellow's name. So he was very angry, So what he did was he made another fellow call him for a cup of tea in London and put a very small amount of polonium, is this clear, in his tea and fed him. The radioactive poisoning was so much. Fellow's name was, he died a very miserable death, radioactive poisoning. And England was alarmed that they could do this. So there are two people who are known to have been killed by, like such kind of radioactive power. One is Yasser Arafat, the Israelis did that, and Russians did this too. I forgot the fellow's name. When I remember, I'll tell you. So they had used polonium to poison him. It's no use in India. We are talking that, we are in this country, that country. We could have also done that to Hafiz Sayyid. No? Chai pe charcha, 0.1 milligram. The end. Is this clear? But you need that's where Putin, that's what is Putin. He will not surrender. He will. So he did that. So we have the person is alive. He's created another problem. He did that. He poisoned somebody with polonium in England. So take down this much, and then we will go to the electronic configuration. Priya, when you finish, you tell me. Okay. Now we come to the next one, that is electronic configuration. So when you're talking about electronic configuration, So we have oxygen, sulfur, selenium, tellurium, polonium. You remember this is group 16. I told you I always remember what do I do? We have fluorine, chlorine, bromine, iodine, astatine. This is group 17. 9, 17, 35, 53, 85. Do you remember I told you? What do I do? Just subtract 1. So this is 8, this is 16, this is 34, this is 52 and 84. 83 is bismuth, the last stable element. So I always remember like that only. I have by hearted only the 17th group, 9, 17, 35, 53, 85. So writing the atomic number becomes very, very easy. So oxygen will have a configuration 1s2, 2s2 and 2p4. So this will be 1s2, 2s2, 2p6, 3s2, 3p4. So 2s2, 2p4, 3s2, 3p4 is the outer electronic configuration. Once again, why is the outer electronic configuration so important? Because I told you, it is the chemical property of an element is because of its outer electronic configuration. Then we have, see, 21 to 30 is 3D is getting filled. This is 34. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p4. Then you have, see, 57 to 71, the 4f will get filled, that is lanthanides. Okay, here this is 52, so 4f will not get filled. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Okay, then you have 4s2, 4p6, 4d10, then you have 5s2, 5p4. But here what happens, 51 to 57 to 71, okay, what happens is you get, this is 84, so it will have a configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 4f14. Then we have 5s2, 5p6, 5d, 6s2, 6p4. Okay, and I told you once again, I'll mention it once again. Polonium, oxygen, sulfur, after 83, after atomic number 83, bismuth, all other elements are what you call radioactive. So the first radioactive element happens to be first naturally occurring. Artificial you can get many. So the first, so polonium has two distinction. What are the two distinction? First naturally occurring, first naturally occurring. Radioactivity we can write like this shortcut, radioactive element, that is the first, and second is most radioactive element, strongest radioactive. Most radioactive, that would be right. That's how it is, most radioactive element among the radioactive metals, polonium. Take down this much, then we'll come to the next part. RA stands for radioactive. You know, that shortcut is allowed actually. Okay. Now we come to trends in physical and chemical properties. of group 16. So what we have is trends, physical and chemical property. Trends in physical and chemical property of group 16. The first is what? Physical state and molecular structure. So you have physical state and molecular structure. So oxygen is a diatomic gas. Oxygen is a diatomic gas. I don't have to tell you much. Whereas sulfur, selenium, tellurium, polonium, they are solids. Okay. Polonium is radioactive, that I don't have to write again and again. Okay. Now sulfur and selenium, okay, exist as octaatomic molecule. Exist as octaatomic molecule. So sulfur S8 is this clear? S8, it is called as either crown shaped structure but you will see in all books it is also called as puckered ring structure. See, what is the meaning of puckered ring structure? If we just make our lips like this, so 1, 2, 3, 4, 5, 6, 7, 8. This is how the sulfur atoms are arranged in two planes. So this is called as, this kind of act is called as puckering in English. Is this clear? So when you make it like this, the way the shape is exactly how the 8 atoms are arranged. It is clear? So it would be something like this. So remember, from the board exam point of view, you have to know the exact what you call angle and the bond length. So you have puckered ring structure. So each is a sulfur atom. So your angle is 107 and your bond length is 204 picometer. So now, and then what happens is, now they'll ask why sulfur has, now this is a question with the scientific reason. This is clear. Why sulfur has higher melting point compared to phosphorus? The reason is very simple. It is octaatomic, more van der Waals. So since the molecule is octaatomic, since the molecule is octaatomic, what is happening? There is increase in van der Waals force. Increase in more the number of atoms, greater is the van der Waals force. Increase in van der Waals force. So that's the reason why what happens? We say sulfur has a higher melting point. So sulfur and selenium exist as oxygen, sulfur, selenium, tellurium, polonium. So tellurium and polonium are basically what? They are metals. Is clear? So metals have metallic bond. Okay. Then what happens is we come to density. Atomic radii, ionic radii increases as we go down the group. No deviation, so that is a normal. Now take down this first. Then we look at density. Priya finished? Okay. Now we come to what? See, there are two things which we can just glance over because it's a regular trend. There is no anomalous behavior, so we don't have to worry. The first is density. So as far as density is concerned, we can just say because the atomic weight increases, so density increases as we go down the group. So third point is what? Density. Not much to be discussed. So density increases as we go down the group. So since there is no anomalous behavior, a question cannot be framed. When we have an anomalous behavior, then the question starts getting framed. Then after density, what do we have? We have electronegativity. Here there are 2 points to be discussed. Electronegativity. Okay, what happens is that they have a higher electronegativity value as compared to group 15, where as we go in a row, electronegativity increases. Is this clear? So with that logic, group 16 elements are more electronegative group 16 elements are more electronegative than group 15 elements. Group 15 than group 15 elements. Okay, but the most electronegative element happens to be fluorine. The most electronegative. So that I think everybody knows fluorine is the most electronegative element. But they can question you on the other part that oxygen has, or is not has, oxygen is the second most electronegative element. Oxygen is the second most electronegative element after fluorine in periodic table. Whole periodic table among all the elements. Most electronegative element is fluorine, then we have oxygen. According to the Pauling scale, it is 4. So here this will be equal to what? 3.5. So fluorine has a value of 4 in Pauling scale. Oxygen will have 3.5. Then chlorine will be 3. Okay, that we'll see in the next chapter. Oxygen is 3.5. So this value may be useful in the sense that this can be asked as a factual value. So take down this much. Next we'll go to melting and boiling point. Okay, then we come to, there is now the next one. Why I did not continue is because the next one is important. When you come to melting point, because of inert pair effect, there is a slight change in the trend of melting point. Normally, melting point has to go on increasing. Why? Because the atomic size increases, the number of the atomic weight also increases, so automatically, and then it's transitioning from a non-metal to a metal. But here what happens? Polonium has a slightly less, so melting point and boiling point. We'll go by the general rule. Melting point increases Melting point increases as we go down the group. As we go down the group. But polonium has melting point less than tellurium. That is because last time I had told you extensively, if you have forgotten, see the recorded lectures, I have told you what is inert pair effect. This is because of inert pair effect. So if we write the values of melting point, now see we have oxygen, sulfur, selenium, tellurium, polonium. The value is in Kelvin. Okay. So oxygen has 55. Then this is 386 Kelvin for monoclinic. And then this is 490, keeping up with the trend. Okay. Then this is 723 and this is 527. So what kind of a question can be asked? Increasing order of melting point. How will the question be framed in the entrance exam? Increasing order of melting point of group 16. Increasing order of melting point of group 16. What can we say? It is oxygen less than sulfur, less than selenium, less than polonium, less than tellurium. So which will have the highest melting point in group 16? It is tellurium. When we come to boiling point, again the same thing. So I'll write the boiling point over here. So it becomes easy for you. So when you come to boiling point, we have oxygen, sulfur, selenium, tellurium, polonium. That is in Kelvin. So this is 90 Kelvin. This is 718. This is 958. And this is 1263. And this is 1233 Kelvin. So once again, oxygen less than sulfur, less than selenium, less than polonium, less than tellurium. So this is how they will ask in the entrance exam. So please take down. So remember, MCQ can be asked which has the highest melting point, which has the highest boiling point in group 16. So remember, it is not polonium, it is tellurium. We are finished.
Yeah.
The next one is electron gain enthalpy. Electron gain enthalpy. So what is electron gain enthalpy? It is the energy released. Generally, it is energy released, but here in this case, it will be a problem. Remember that. For oxygen and sulfur, the energy released or absorbed when an atom accepts an electron to form an anion. Atom accepts an electron to form anion. So please understand what happens over here is, if you look at the first electron gain enthalpy value, you have oxygen, sulfur, selenium, tellurium, and polonium. Oxygen has a value of minus 141 kilojoule per mole. Sulfur has minus 200 kilojoule per mole. And this is minus 195 kilojoule per mole. Tellurium has minus 190 kilojoule per mole. And polonium has a value of how much? Minus 183 kilojoule per mole. Okay. Now from here to here, it decreases. If you look at reverse, oxygen should have had the maximum electron gain enthalpy. So this is a question which is asked always. So GSR means give scientific reason. Electron gain enthalpy. This will be anomalous behavior of oxygen also we'll see. Electron gain enthalpy of oxygen is less than that of sulfur. Why? First and foremost, write down small atomic size. Okay. Then what happens? Highly electronegative. Highly electronegative. The third point is, like I told you in the earlier case, nitrogen. Here also the same point. The incoming electron faces tremendous incoming electron faces repulsion. Incoming electron faces repulsion. So some energy is used to overcome the repulsion. Some energy is used to overcome repulsion. That means we might have expected something more than 200 kilojoule, maybe 250 kilojoule. But nearly 160 kilojoule is used for what? Stabilizing the anion. Are you understanding? So the net energy released becomes less to overcome repulsion. One very important thing here you should know, I taught this in thermodynamics, I'm again teaching you. See, oxygen generally has 6 electrons, it requires 2. So O to O minus 1, this delta electron gain enthalpy is this value. What do you tell you? It is minus 141 kilojoule per mole. But remember, O minus to the stable oxide ion, what happens? The value is nearly Yeah, we have over here oxygen. It is plus 844. Is plus 844 kilojoule. So this is what they ask, the entrance exam question, which reaction is endothermic? Which reaction is endothermic? You can see O to O minus 2 will be endothermic because 844 minus 141. So delta electron gain enthalpy H will be equal to how much? This is 3, this is 0, and this is so plus 8 plus 7 plus 703 kilojoule per mole. The other one is sulfur. This is a straight question, same question, which is endothermic. S to S minus 1, that value I have given you already. How much is it? It is delta electron gain is minus 200 kilojoule per mole. But normally we don't have S minus 1. We have you have S minus plus an electron. Stable is S minus 2. So that is delta electron gain enthalpy H is sorry sorry plus 532 kilojoule per mole. So what happens is S to S minus 2 by gain of 2 electrons. It will gain electron because there's 6, it wants 2 electron. So this delta electron gain enthalpy will be equal to how much? 332 plus 332 kilojoule per mole. So this is what? This is endothermic. So don't be under the impression that always electron gain enthalpy is what you call is exothermic. These are two frequently asked questions in the entrance exam. Please take them. No. They will ask, say, F minus, fluorine, chlorine, bromine, and then sulfur. Fluorine, chlorine, bromine, oxygen. Are you understanding? Like that. So net stable anion of oxygen is O minus 2. Stable anion of sulfur is S minus 2. So that, okay, we have only about 4 minutes. So please take down this much. You can leave the portal and we'll continue with oxidation state and chemical properties. For those who are watching my live stream, the next lecture is on Sunday, this Sunday, that is day after tomorrow at 5 p.m. So please join in.